signal strength. So you have this particular one is a decagon. I know John Deere sells one with their Field Connect, but essentially it works in the same technology. This one you would bury down to the corkscrew on it. So you drill a small pilot hole, and you put this into the soil. There's a line here, and then it gives you a reading at, this one does 10 centimeters and 20 centimeters. They sell them in different lengths. That's the one benefit with these, is that you only need one axis tube and you can get multiple depths, where a TDR you have to do what I do, where in the field you have to dig a small pit and insert at different layers, or you have to buy multiple of these to get down depth. Key with these are, though, there needs to be good contact, because again, air has a 1 value, water is 80. That air can really throw off the readings in this type of a sensor. These ones are a nice little unit in that it's all one unit. That there's a cell modem in each of these heads, so it's a solar powered, and you just mount it on your field. It transmits the data to a server, a service provider, and then they turn around and give you the soil moisture content at the different depths along the probe. So again, here's kind of like, there's the John Deere Field Connect, but here's the readout from this. It's called a Daycom sensor. It's a company out of the Netherlands. But as you can see, this was planted out at the research farm. You can see the light colored is the 10 centimeter soil moisture profile. The green is the 20 centimeters. So you can see how we're maintaining the soil moisture at a decent level, and you can see how it draws down at the end of the year when it really starts picking up. Newer technology, I don't know if anybody's been out to CSADC field days, is the new innovation called Smart Drop. These still are kind of in the development stage. It's basically, again, measuring microwave emissions from the soil, and that's proportional to the water content of that soil. This is now an indirect method of measuring soil moisture content. So those big discs on the pivot, mounted to a pivot, are antenna. They're picking up this measurement, and then the service provider will calculate the moisture content depending on the type of soil, but between 15 to 30 centimeter depth, kind of the average soil moisture content, and then we'll generate a map. So these are mounted usually every span on the last 5 spans, and then every time it goes around the field, it'll generate a map similar to the bottom. But again, he's still getting off the ground, so this is a fairly new technology. Go into that. Next is plant-based. So if you hear about people discussing plant-based systems, again, plant-based system won't tell you how much to irrigate. A plant-based system is just giving you an idea of either A, how healthy the crop is, or B, how stressed it is to water. So it's kind of giving you an indication if there is stress, but you still have to estimate or find a way to calculate how much water to apply. But it is a good triggering unit. So again, it needs to be paired with another method. So common plant-based methods are infrared. So this is our drone at work. We'll have a gimbal with a thermal camera on the front. We'll be able to fly over the field, and it'll give us a good indication of what the crop canopy temperature is. So the reason that's important is that when a crop transpires, it essentially, it's like you sweating. It allows you to drop your temperature compared to the surroundings. So if that crop canopy temperature raises closer and closer to the actual air temperature of it. The idea is that it doesn't have sufficient amount of water to transpire and cool itself down. So that, again, that's the trigger that it should be time to irrigate. Here's some of the work that Jay's going to talk about a little bit and what he's done. But again, it's excellent in terms of spatial variability. This little pie here on the right shows this bottom right is a sandy area that it's usually low in water. So I mean, it's heating up quite a bit more than the healthier area where there's good growth but also good water, so it was allowed to cool itself down. NDVI. NDVI is kind of a term that's kind of seen a lot of use lately. So again, it's just a way to take some visual sensors, and so you're looking at the red and the infrared spectrum of what's coming, reflected off the crop canopy, and that'll give you an indication of how healthy a crop is. And so if we've got a crop here that looks fairly green on the left, we'll give you a value closer to 1. Value 1 means a dense crop, quite healthy, where as you get down to 0, the crop is not as green, the greenness is down, so it isn't as healthy. The idea here in irrigation scheduling is that a healthy crop is going to use more water, which makes sense, and a drier, sicker crop is going to use less water. So it's really, again, not an indication of how much water to apply, but how fast the crop is using water. So again, newer technology. This is called an Arable Mark. I haven't tested this one out yet. It sits out in the field. It's an all-in-one sensor, so it measures different environment, like wind, temperature, air pressure, rainfall, but it also incorporates this NDVI and thermal. So if we go back, the AIM model that Joel had kind of mentioned essentially comes down to ET. So it calculates an ET based on local weather inputs. Then it uses a crop coefficient, so whatever crop you've entered, and the stage of development, and it uses that to estimate what your crop's using as a baseline. Where the new idea of doing things is actually taking a measurement using NDVI to get a more accurate estimate of this KC. These KCs were developed late 80s for general crops. So I mean, if you can get something that's a little bit more site specific, the idea is that you would be more accurate in your estimation. So again, this is an all-in-one sensor. You mount in your field and it'll actually generate these irrigation schedules for you. Sensor issues. Location is everything. Again, with the soil sampling and everything, make sure you put it in a field in a location in the field that is very representative of your whole field. Don't put it in this low spot and then have it flood halfway through the year and get no decent data. Placement installation is also important, especially like the capacitance probe. You don't want that air gap around the probe. TDRs, these ones aren't too bad, but the pits that you have to dig and insert horizontally, you just got to make sure you compact that soil back up to somewhat field conditions, because if you don't, I mean, water's going to infiltrate a lot faster through a loose textured field. Wiring, you know, wiring issues all the time. This is some of my research data. You can see I lost about 2 weeks just from a loose wire. So always double check wiring. And again, if it doesn't make sense, go check. Take a spade out there, check the soil moisture at location and compare it to what the sensor's reading. I mean, sensors are infallible. They will have issues all the That's it on irrigation scheduling. Is there any questions before we get into VRI?
The thermal resolution pictures, when are you flying? What type of days, how many times?
Usually with thermal, you tend to want to capture around that peak sunlight hour, so you're looking at that 10 to 2. I mean, early in the morning and late at night, you tend to not get that difference. I mean, that peak difference where you're really going to see that stress is going to be midday. This Arable Mark has NDVI, but also has a thermal sensor in it, so it'll measure the ground, but it's only taking, I think, 1 sample a day at high noon, and then comparing that between days.
Can you set that time when it's taken it?
It's preset, but I haven't used this yet, so I don't know much about it. I just got it actually a couple weeks ago. But yeah, with the thermal, the problem with thermal right now is it's still expensive technology. It is coming down. Like the thermal camera on my drone, a good thermal camera is going to cost you about 10 grand. But there's nothing saying, I mean, the idea and the concept has been around for a while, and there's nothing saying you can't use the $30 IR thermometer from Canadian Tire, right? I mean, you're just taking a spot measurement, but if you're out in the field and you take a couple spot measurements at noon, then you kind of get an idea of what that differential between your crop canopy and the atmosphere is. Problem is, a lot of this equipment is getting there. Its prices are still somewhat expensive, but it is coming down. As you see more providers come out, you're going to see more products available and the price come down.